Hi, my name is Neil. So everyone must have been told some point of their life that tuna contains mercury. Tunas are predators, so they are at the top of the food chain, alongside sharks and swordfish. Also, they have a very long lifespan, so mercury, more specifically methylmercury, will accumulate in their fat tissues. But do they actually contain detectable mercury? You will find out after watching this video. A month ago, my friend Kelly, who is doing some research concerning the mercury contamination in the Bay Area, and asked me the method of determining mercury content. This quarter, I'm in an analytical chemistry lab, so after talking to my lab partner Gabriela, who has access to an inductively coupled plasma mass spectroscopy instrument, we decided to do it ourselves. Kelly bought 6 types of tuna from the local seafood market. We live in Santa Cruz, and all fish sold here are caught locally in the Bay Area. So here's how we did the experiment. So right now, we just added some nitric acid and hydrochloric acid together. We are making aqua regia, and aqua regia will wash those volumetric flasks so that there be no metal left, because aqua regia can dissolve every single metal basically. It can even dissolve gold. So we have finished cleaning and labeling. So these are the 6 different samples we are going to analyze. We've finished weighing the ahi. Mass is 0.534 grams.
Ugh, I hate the smell. Okay, this one is gonna be easy to break apart.
What is it?
Fuck. The skipjack.
So we have already put all the fish into the flask, and now we are preparing the acid to dissolve those fish. So right now we are going to make piranha solution. It's 3 parts sulfuric acid and 1 part hydrogen peroxide. So this is 30% hydrogen peroxide. This is not something you can buy from CVS. I guess in CVS is only 1/10 as concentrated. In CVS usually it's 3% hydrogen peroxide. 30% is actually very dangerous because a very good oxidizing agent. When that is added into sulfuric acid, it will gasify all organic carbon and inorganic carbon too if you want to sprinkle carbon polymer in it. Okay, so we've already put the first fish into the piranha solution. It might take some longer time to dissolve, but you can see like the fish is already like breaking down in the flask. As you can see, ahi is almost dissolved, and we just add the solution for albacore. Is being dissolved. Looks cool. Ahi is basically gasified already. I mean, some fish are more breaking down than the others. I expect ahi to dissolve a little bit slower because ahi, the chunk is very hard. So just to make sure everything's dissolved, I'm gonna add 1 more milliliter of peroxide to each flask. It's been almost 2 hours since we start to make the solution. Most of them have pretty much dissolved because bluefin and yellowtail start pretty late, so they too probably take a longer time. Bluefin, I can see it's being dissolved right now. I don't know what's going on with yellowtail. Yellowtail is right now so far the most resistant. I would feel really bad if yellowtail does not dissolve totally. Hopefully yellowtail will dissolve sometime later. So the first fish has some black goo in it, almost dissolved. Albacore raw. Pretty good. I'm pretty satisfied with albacore raw because it has one of the least residues left over. Skipjack for some reason foamed a lot, but it dissolves really well. I'm assuming that because it's the softest and it was broken down the best, and that's why it reacts the best. Canned albacore it's almost gone. There's only a little bit residue left. Bluefin's getting there. We did bluefin last, so bluefin might need some more time. I have no idea what happened to Yellowtail. Yellowtail just refused to be broken down by the acid. So now we are almost done for the day, so we let them sit for the night. We put Kimtech towels in the bottles so that dust won't fall in and air can still go out, because we don't want them to explode either. It's been left overnight.
Both albacores are completely dissolved.
Albacore completely dissolved. Yellowtail.
Skipjack.
Yellowtail completely dissolved. Skipjack completely dissolved.
The ahi, yeah, pretty much like
ahi is the most firm one, so I expect.
No, bluefin, right?
That's crazy. Like just like several drops dissolve the entirety of the chunk. Yeah, I expect skipjack to be pretty much gone because skipjack was the softest one. This is day 3. Yesterday after I was gone, my lab partner diluted everything but the bluefin because we thought bluefin didn't dissolve all the way. I mean, there's still some residue. I might add some more peroxide in it. I foamed quite a bit. I don't know if that matters. The rest we already diluted it and capped it. Albacore completely gone. 100 ml of albacore solution. I cannot believe I say this out loud in my life. Yellowtail, pretty yellow. Oh my god, I don't want to die this way. Albacore, raw, dissolved. Skipjack, completely dissolved. Ahi, completely dissolved. I really don't want to die this way. You don't see any residue. All organic matter's gone.
You need to kill someone though.
Yeah. So there's still some particles in the solution, so we might have to filter it so that it won't clog the machine. I'm adding some more peroxide right now to bluefin, hoping it will digest the last bit chunk. See, the solution is still a little bit cloudy, but we might still want to filter it so that it doesn't clog the machine. Also, like, this is a very highly acidic and corrosive solution, way more corrosive and digestive than our stomach acid. So if there's some insoluble inorganic parts that still left in the flask after we filter, then the mercury content will not matter as much, because if this cannot dissolve this, then I'm pretty sure our human body will not dissolve it anyways. So we will probably just do the mercury content in the solution form. Okay, we're gonna vacuum filter these things, but we have to wash with aqua regia first. I just made some aqua regia here, which is again 3 hydrochloric and 1 nitric. It can dissolve gold. Aqua regia, golden liquid, very, very pretty, so pretty. Okay, so now we filtered ahi, so there's no solid chunk left in the solution. This will be the solution we'll be using for analyzing. We're still filtering our stuff. There are 4 done, 2 to go. We are doing skipjack right now, and skipjack is the best because it dissolves the best from day one. It reacts the fastest with the piranha solution, and now is like there's barely any solid residue left. Nice to know. Okay, now we have finished filtering. We have stored all the solutions in individual bottles. As you can see, they are all crystal clear. It's very, very trippy for me because only 2 days ago they were a big chunk of fish flesh, and now they are crystal clear liquid.
Let me fire it up and we'll get it rolling.
Which machine is that? This one? This one?
Instrument.
Instrument.
Know the difference between machines and instruments?
Kind of.
Machines give you mechanical advantage. Instruments extend your senses. Mechanical advantage. Right? So a car is kind of a machine.
Bicycle is a machine.
Bicycle's a machine. But this lets you look at tiny things.
Okay, wow. Yeah.
Oh, we'll look at 9, 200, 1, 2, 2, compare that to a 4.
So Allie might be trying to come out this weekend. If you want to try and go this weekend. Otherwise, I think we're going to try and go regardless.
Well, so it goes in the back.
Where?
And there's little feet on the tray and little holes in the rack.
Where are the
It's got to slide into.
kind of weird. No, they're not
It's
going.
actually the hardest part.
Oh, yeah.
Getting the feet to line up.
This is the hardest part.
Yeah, it's the worst. It's the tough. You got
Yay.
it. That's
Yeah.
it. Okay.
No.
And then the same experiment. Tell it to go.
This is 200,000.
The laser. No, I don't think it's 2. Maybe 150.
Okay.
Something like that. The ICP is about 150.
Okay. So what is the robot arm doing right now?
I told it to run the nitric. So I'm using a 1% nitric acid as a rinse wash solution in between your samples. So I told it to run that twice at the beginning, so you'll have sort of a blank.
First blank, or should I still just make an average of the 3 blanks?
Well, if two of them, if you let two run, is the high blank significant compared to your samples?
It is analyzing here right now. It will rinse, yeah. It will rinse in the nitric acid in between runs. This curve above, meaning that we saw mercury. Now we've done ahi, ibuprofen, and raw. And as you can see, ahi so far has the highest concentration, and raw has higher concentration than can. Guess what? Bluefin has the highest, by far, mercury content of all fish we analyzed. And now we are analyzing some 200 parts per billion mercury standard to figure out how it compared to a standard. So after we did the 200 parts per billion mercury solution as the standard reference, we were actually very surprised to see that the bluefin solution's mercury content was even higher than that of the mercury solution. Especially the dissolved bluefin solution was already diluted to 100 milliliters. So is there actually evidence that Bay Area water has a higher concentration of mercury than the other parts of the country? Yes. Based on an article by KQED Science, in the 19th century, gold rush miners mined mercury in the Sandbar Rich Hills south of San Jose. Sandbar is chemically known as mercury sulfide, and it is the most common source of refining mercury. The mercury extracted from Sandbar will be used to trap gold from crushed rocks, even though they later switched to cyanide. Yeah, I know, not very friendly either. creeks and rivers still flow through the abandoned mines and into the San Francisco Bay. Roughly 2,000 pounds of mercury enters the bay each year from all sources. The mercury in the water will be collected by bacteria that turn it into methylmercury, a highly toxic compound that can accumulate in organisms and give them permanent brain damage. In the 90s, there were substantial reports that low-income families in the Bay Area that relied on an almost all-fish diet suffered from mercury poisoning. The Water Board estimated 100 years for the bay to recover. 3 generations at minimum will continue to be impacted from the high concentration of the methylmercury in Bay Area seafood. Now I'm going to do some math and evaluate our method of research. If this is too boring for you, feel free to skip this part. So here I'm going to show you guys how we did the calculations. You guys can check our math in the comments. We'll use ahi fish as an example, and we will use Mercury 199 as the example for the isotopes. So for that particular isotope, the ICP-MS instrument gave us a reading of 13,665.951 intensity for the 200 ppb mercury. This gave us an intensity of 68.33 for every parts per billion mercury. The reading for the ahi fish is 1256 intensity divided by 68.33 gives you a 176.44 parts per billion mercury in the ahi fish. Convert to parts per million is 0.176 parts per million. 1 parts per million equals to 1 milligram per liter. So this number will give us 0.176 milligrams per liter of mercury. We were analyzing 100 milliliter, which is 0.1 liter. This will give us a final result of 0.0176 milligrams of mercury. We used 0.534 grams of ahi fish. This will eventually be converted to the FDA standard, which is a microgram per gram, which is 33.041 micrograms per gram. Is it a lot? Yes, this is a lot, because after measuring the mercury content across the nation, the FDA has average max of 0.35 micrograms per gram. This is the FDA max mercury from all over the nation. So this number we got from the instrument is almost 100 times higher than the average. We did the calculation for every single fish, and every single fish was more or less 100 times more concentrated than the FDA average. What does it mean? It could mean nothing. It could simply mean we did something wrong. But since we washed every single glassware we touched with aqua regia, an acid which can dissolve gold, we couldn't think of any source of extra mercury with the same percentage distributed to each fish we used. So we didn't do a piranha blank. Right now, when we think about it, we could have done a piranha blank. Only dilute piranha solution to 100 milliliters to see if that number will also give a high number. We didn't do it. We regret. And we also should have had more Mercury standard. This calculation is based on if we actually believe that 200 parts per billion Mercury was actually 200 parts per billion. If there's any error in that standard reference, the calculation will be redone. But if assuming that we didn't do anything wrong with our calculation, and there's nothing wrong with the standard reference, and there's nothing wrong with the ICP-MS instrument, which means every single fish that we analyzed has a higher mercury content from the average tuna mercury content by 100 times. So like I said earlier, there has been substantial evidence that Bay Area water definitely is contaminated with a high amount of mercury. And there actually have been evidence that some people living in the Bay Area who had the fish as their basically only diet developed mercury poisoning symptoms. So personally, I believe that we didn't do anything too wrong, and therefore my personal conclusion, correct me if I'm wrong in the comments, that Bay Area tuna actually has a higher concentration of mercury than the average from other parts of the American oceans. Tell us what you think in the comments, and thanks for watching.